Alright guys, here is part 2 of the free response test review. So here we're looking at two piecewise defined functions. Okay, so task A asks us to identify the domain of both functions using interval notation. Okay, so we need to look at the constraints, right? Now we notice for the first function, for f, we have a constraint that goes from -4 to -2, where we're open at -4 and closed at -2. And then we pick right back up with our second constraint starting open at -2 and then going out forever to infinity. Okay, so really the domain for f is going to be the open interval starting at -4, and because -2 is covered on this function, even though it's open at -2 for the second function, we are just going to have one interval going out from -4 to positive infinity. Okay, so without even graphing, I know that that is the case. All right, now for g, g is a little more interesting. We'll notice that we have one constraint that is simply less than -4 and another where x is greater than -4. Now, neither of these domains are going to include the value x equals -4, which means that at -4 we would have an open circle on both functions. So we're going to have two intervals. We're going to have one that goes from -infinity to -4, and of course open on both ends, and another, right, so union, the interval from -4 to positive infinity. Okay, so those are my domains for f and g. Next we have to find the values of f of -2 and g of f of 3. Okay, and it says show your analysis. So really the first one, there's not a whole lot to show other than the work that gets us our answer. We know that -2 falls into which of these two constraints? Well, the value -2 is included in this first constraint, so we're going to use the top function. All right, so we have f of -2 is equal to 1/2 times -2 squared minus -2 plus 2. And that's 1/2 of 4 plus 2 plus 2. And that's 2 plus 2 plus 2, which is 6. Okay. Now for g of f of 3, we need to work inside out. So really we need to find f of 3 first. Right, we're working right to left. F of 3, well, 3 falls above greater than -2, right? 3 is greater than -2, so we know that we're going to use the bottom function. We've got the square root of 3 plus 6 plus 4. Square root of 3 plus 6 is the square root of 9. And of course the square root of 9 is 3. And 3 plus 4 is 7. Okay. So if f of 3 is 7, that means that g of f of 3 is just g of 7. Okay, now we look at our constraints for g. 7 is in fact greater than -4, so really we're just going to plug 7 into the bottom function, which is -1/2 of 7, which is -7/2, or -3.5. -7/2 is perfectly fine. All right. Next question is, well, the next two questions, I should say, are ones that we haven't really talked a whole lot about. So you're going to have to kind of just be open-minded here. Although this might come as a surprise, you can easily use your imagination to determine what continuous might mean, right? So let's see what's going on. I'm going to check the situation. So when x is -2, let's look at f. Let's figure out what's going on here. -2 is part of this first constraint. It is not part of the next constraint, right? So the only situation where f might not be continuous is if we end here and then pick back up right at -2 at a different output. So really what I need to check for and see is if those two outputs of the two functions in f are the same when x is -2. All right, so let's check it. We have 1/2 times -2 squared minus -2 plus 2 was equal to 6 from above, right? We already did that work. Okay, now we need to see if the square root of -2 plus 6 plus 4 is also equal to 6. Okay, square root of -2 plus 6 plus 4 by simply plugging -2 into the bottom function right up here. Right? -2 plus 6 is equal to the square root of 4 plus 4. And the square root of 4 is 2. And 2 plus 4 is 6. Okay, so because the function is equal to 6 for both the top function and the bottom function, that means that although the second function is open at x equals -2, the outputs are equal. Thus, f of x is in fact continuous at x equals -2. Right, so the answer is yes. F of x is continuous. So really you can kind of picture what's happening, right? You don't need to graph this, but you do kind of need to understand that because this is a degree 2, it looks like a quadratic, right? So it kind of has something going on like that. So what's happening on the right-hand side of this quadratic? Sorry if you couldn't see that. Well, it's closed on this end, but then my square root function is going to pick right back up at the same output and do something like that, right? So if you think about the graph, really continuous just means I hit this point, and do I have to lift my pencil, or my pen in this case, to pick back up and finish drawing the graph? The answer here is no. I can draw this part, stay right there, and continue. And that tells me that the function is continuous. Okay. Now, next question is g of x continuous when x is -4? Right? So we need to look back at our g piecewise defined function, and really, in this situation, we don't even have to do any algebra, because when x is -4, we are not on either constraint, right? We do not live in either neighborhood. So what that means is I know g is not going to be continuous because I would have to lift my pen to draw that graph, right? Whether it looks like this, with a hole, and then like that, okay? So the two functions might actually meet right at -4, but there's an open circle there because -4 is not included. Or we might have a situation where we have one piece of the function that does that, and then another piece of the function that does that, or any combination of those situations, right? Even if they were to meet at -4, the fact that we have an open circle tells me that the function is not continuous. And especially if we have to pick up and go to a completely different location when drawing our graph. That for sure tells me the function is not continuous. So, without doing the algebra, so to speak, I know g of x is not continuous at x equals -4 because even if the outputs were equal, there would still be a hole at x equals -4, as pictured on the left over here. Right? So g of x is not continuous at x equals -4, so the answer here would be no. And that's it. So once again, I'll zoom out so you can see the big picture. And there you have it, guys. That's free response number 2. If you have any questions, please feel free to email myself, and I'm pretty sure Mrs. Keener would respond to an email or two as well, though I cannot speak for her. So, if anything was unclear, let me know, or come to tutoring and we can talk. All right, guys. Hope you're ready for this test coming up on Friday. We'll talk more tomorrow.